measures of position and outliers. Okay, number one, we're going to talk about what is called the z-score. The z-score compares two different data sets, maybe even with different measurement units if that's what we want to do. Hopefully not required. But we'll get to an example in a minute. I already have an example for you in a few seconds. So what does this z-score do? It tells us the position of an entry, shows the position of an entry or data value with respect to standard deviation. Relative to standard deviation, if that's better for you. So then the z-score is any entry minus x bar divided by the standard deviation of the sample. So if now we look at the first example and we want to compare, so for a population and for the sample, of course, it will look differently. So this is for the sample. And the z-score for the population will be, of course, this is xi. It can be xzi for any entry. You can write it zi corresponding to this. It's z1 for entry x1, is z2 for entry x2, and so on and so forth. And in general, it's x minus mu divided by sigma for a population. So this is for a population. Of course, it looks different because we are using different notations. But this is, again, xi, any entry, minus mu over sigma. And let's see how this works. Because we may want to compare two entries in two different data sets. And I have the data set already summarized and analyzed with a mean and everything. So example 1. So z has no measurement unit, very important. And it has a mean of 0. Please write 0. The mean of z is 0 and the standard deviation is 1. So you are going to see me write this in the following form. It's normal, and you'll see that when we get to it. I just want to warn you from the beginning. This means the mean, and this is the standard deviation. Mean, standard deviation. And this, we'll talk about it later. It's a normal distribution. Normal distribution. We need to know this from now, but not a lot of details yet. So z is a normal variable. Normal. That's how we use it. We use a squiggle like that, like approximate, but just one squiggle. Normal with a mean of 0, standard deviation 1. So I would like you to remember what this means. Okay, so finally let's go to our example. Example 1. The mean height of males 20 years or older is 69. So for males, I'm going to write x bar 1 equals 69.1 inches, of course. With a standard deviation of S1, 2.8 inches. See, if I don't write this, but if I write S1 squared, because it's for males and we have to compare, then I will get whatever inches squared. Who cares about this? How can somebody's height be, when I square it, it doesn't mean anything for us. We're not talking about surface here. So we're not going to use the variance. With standard deviation of the mean height for females, to differentiate, I'm going to call it X bar 2 for sample 2. 20 years of older or older is 63.7 inches. And the standard deviation of 2.7. Okay, so now, who is relatively taller? Kevin, from the males, whose height is X1, 83 inches, or Candace, whose height is 76, so X2, 76 inches. So,
Kevin is taller.
Say it again.
Kevin is taller.
Okay.
Very tall.
But we still have to compare relative to the sample that he's coming from. Okay, so let's do that and then draw a conclusion. So we will determine for Kevin, we will determine his z-score, z1, which will be his height minus the mean height in his sample divided by the standard deviation of his sample. Also, we are going to determine for Candace her entry, her height minus her mean from the sample she's coming from divided by the standard deviation of her sample. And now we will see which one is relatively higher, taller, of course. Make sure that you put parentheses. If you want to do this with a graphing calculator, make sure you put parentheses around the numerator. So I have 83 minus, because I want to do it in one step, and divide by 2.8. Please do it in one step. So I see 4.964. Let's see the other one. Parentheses, don't forget, 76 minus 63.7 and divide by 2.7. The higher the z-score, the higher the relative comparison will be. So very good. It turns out that the z-score for Kevin is higher than the z-score for Candace. So then we will say indeed that Kevin is relatively taller. So that's our conclusion, based on enough information, satisfactory calculations. Kevin is relatively taller. Kevin, let me write like this, is relatively taller. Z-score, Z was 4.964, which is higher than 4.555. So with the z-score, we can relatively say position. So it's a measure of position. It tells us where an entry is in the respective data set. That was number one. Number two, percentiles. These are not percentages. They are related, but we're not talking about percentages. So what percentiles are in a data set? They are denoted by PK. K being the fifth, the 10th, the 10th percentile. Okay, so if I want, let's say, to determine P20, which means the 20th percentile, I will divide the entire 100%, the entire data is here, 100%. I will divide it into 5 equal parts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The 20th percentile is this entry, where 20% are below this entry, and 80% are above this entry. That's the 20th percentile. So an example, which we don't have to do anything, I just copied it for us to understand what it means. The GRE is a test required for admission to many U.S. grad schools. The University of Pittsburgh Graduate School of Public Health requires GRE score no less than 70 percentile for admission. So where will the 70, so P70 be? So again, I have to divide the entire 100% into 10 pieces, and I'm going to say that this is my 70th percentile, P70, right here, which means they require that 70% of the scores are lower and 30% are higher. So for you to say, I'm in the 70th percentile, it means that your score for GRE test is such that from all people who took the GRE test at that time together with you, or maybe total, general, depending on the situation, 70% had a lower score than yours, and 30% had a higher score than yours. And you are 70th percentile. Okay, so that was number 2. Number 3, we have quartiles. And they are 3 quartiles. Q1, Q2, which is the same with the median, and Q3. This is the same with P25, the 25th percentile. Of course, this is the same with the 50th percentile. And of course, this is the same with the 75th percentile.
Professor, so that's quartiles, not outliers, the outliers?
We haven't talked about outliers yet.
Okay.
I'll explain what outliers are.
I arranged my pages incorrectly again.
So I always number them, so they're always numbered at the bottom.
Thanks.
No problem. So let's analyze where this, in any data set, this is the median or Q2, the second quartile. Up here somewhere, it will be Q3, and down here somewhere, it will be Q1. So this is 25%. Doesn't really look on my graph. This is 50%. This till here is 75%, and then we have the whole thing. So Q1 is exactly nothing else but the median of the first half. What is Q3? Is exactly the median of the second half. Okay, so here's our first example of the day, actual example. Let's enter it in both if you'd like. And we're asked to determine and interpret the quartiles, and this is the setup. So this is our data set. Let's enter it in both this time in the graphing calculator. So let me refresh our memory how to do it. Go to Stat and Edit. I'm in love with my data sets here, so I don't want to delete them. So I'm going to use list L9. You can do whatever you want. You can delete what you have, or just go to the next list that is empty. So I'm going to enter all these entries and put them in the calculator. So 20, 24, 27, 28, 29, 30, 32, 33, 34, 36, 38, 39, 40, Sean, where are you? You're not paying attention.
What do you mean, where am I?
You're not paying attention. And look what I was doing. I wasn't even in the correct window. It's your fault. Kidding, I'm kidding, I'm kidding, I'm kidding.
Yeah, I'll lose 2 points for that.
Yeah, and you'll do something and I'll give you 5 back later. I know. 32, 33, 34, 36, 38, 39, 40, and 40. Okay, let's see. 2, 4, 6, 8, 10, 12, 14. Yes, do I have 14? I have 14. Yay! Good. So now, get out of there with second and quit. And go to Stat. And now go to Calc, Calculations. One variable stats. Press Enter. Make sure you have your list. Wherever you enter the data, make sure that's where your list is. So in my case, I have list L9. And I have, make sure that I have L9 in there, and then scroll down to Calculate. Okay, so here's what I read, and scroll down to have all the information we need. So I see X bar, 32.14. I see SX, that's the sample. That is bigger, a little bit bigger, so 6.1751. Please use 4 digits. 2 for the mean and 4 for the standard deviation. N equals 14, as we know. The minimum is 20. Scroll down. X. Now you have Q1, which is 28. We have the median, which is also Q2, which is 32.5. And we have Q3, which is 38. And we have the max, which is 40. So now, we obtained all the information. Find and interpret now the quartiles. And it's all about, we collected data on the speed of vehicles traveling through a construction zone on a state highway where the posted speed was 25 miles an hour. The recorded speed of 14 randomly selected vehicles is given below. Good. So what does this mean? In the middle, Q1, Q2, Q3, Q1, 28, 32.5, 38, minimum, 20, maximum, 40. So, what will Q1 represent? Q1 will represent that 25% of the drivers drove at a speed lower than 28 miles per hour. %, all this, drove at a speed lower than 32.5 miles per hour. This now, 75% of them drove at a speed of lower than 38 miles per hour. And all of them from the data set drove at 100%, drove at a lower speed than 40 miles an hour. How many, for example, between 38 and 40? 25%. How many drove between 32.5 and 40? 50% of those that were in the data set. And that's why we would call the quartiles. It gives us the picture where the bulk of the data, so this is roughly the middle of 50%, very important, middle 50% of them drove between 28 and 38. All of them between 20 and 40. Only 25% between 38 and 40. So as you see the position, we have a lot of information coming from quartiles. Okay, number 4 now. Any questions?